तो चलिए शुरू करते हैं।
Hi guys, today I'm going to make one video on control valve, how to do control valve sizing. So let's see how. So we are going to talk how to do control valve sizing. So we'll see. Suppose this is our control valve. This pressure is P2, this pressure is P1, and this is connected to one pump, centrifugal pump. The suction is here, this is here, this is the delivery of the pump, this is the suction of the pump, this is our discharge pressure, suppose something, and this value is P1, this value is P2. Suppose this is going to this tank, so this is our required pressure, suppose 2 bar. So how we'll do the control valve sizing? For control valve sizing, we need to find out the CV value. In control valve, we have one formula. I will write Q is equal to CV into delta P divided by specific gravity G. In this formula, all units we are taking into the FPS unit. So what we'll do, this all will take in FPS units. So suppose we have a flow, some flow, specific flow, normal flow. I'm talking about this valve, through this valve, 100 GPM. I told you we will take in FPS unit. Maximum flow will take 120 GPM, and minimum flow will take 30 GPM. So what we'll do, this length is L2 and this length is L1. So from Darcy equation, this P1 value will get it delta P rho FL V square upon 2D. We'll put it this length here and get it the delta P value. Suppose we know this discharge pressure is something, so we'll reduce this pressure drop, so we'll get it there. And suppose this required pressure is 2 bar, and this P2 whatever we'll get based on that delta P rho FL V square and 2D. So let this length is L2, we'll put it here, and this delta P will get, and this P2 value will consider this pressure plus 2 bar. So this P1 and P2 value will get it, and according to this delta P1, and this will be the delta P2, this will be the delta P3. So we'll go for this normal flow, suppose. So Q is equal to this CV value delta P divided by a specific gravity. Delta P will take in PSI. Told you will take that all units in FPS. And this specific gravity of water will take 1. So if we'll take this normal flow 100 is equal to CV, suppose delta P, this P1 minus P2 will do for this flow, so we'll get it delta P something, suppose 20 you are getting, and this value. In that way we can find out the CV value. Okay, so CV value what tells? CV value define how much pressure drop will come for a specific flow, and what uh, what flow through the valve at a pressure drop. So this CV value will define this. So based on CV value we are going to do the control valve sizing. So next video I will come for this will define how to consider this CV value. So this is a small video I wanted to say. So then after I will go for the computation of this how to do compute this CV value, this control valve sizing, whatever we are doing this. So we'll go for how to do this apply the CFD here for a valve sizing, how to optimize, and this how we are going to compute, how we'll insert this equation whatever we are using in CFD. This is the video. Bye.